Hello everyone, welcome back to another video in our multi-threading in Java series. And as promised in our last video, today we will be looking into very interesting topic, reentrant lock. So let's dive directly into that. Consider this example where you have a barber shop, a chair where barber cuts hair, a barber and a waiting area where people sit, right? One by one, barber calls a person, one of the person in the queue comes and gets their trimming done. Now, if you had to simulate this scenario using threads, what would you do? You might use synchronized block around the chair to acquire lock, right? Suppose that all these persons are threads who are in contention of the chair. So one of them will acquire the lock and sit on the chair. Fair enough. And after they have their trimming done, they will release the lock and go back, right? And this process will repeat again and again. Now consider another scenario where you have two waiting areas, one for regular people and another for VIPs. So if a VIP is present, he will be given priority. When all the VIPs are done, post that only regular person will be given the chance. Now how will you simulate this scenario? Almost the same. You will use synchronized around this chair. There will be VIP threads and regular threads, right? You will have to maintain maybe a turn variable and maintain number of VIP counts to find out whose turn is it, right? VIP or regular person. Pretty straightforward. This is also doable using synchronized, wait, notify, using a turn variable, using one new variable to store number of VIPs and all those things, correct? Now if there are 3 queues, you can still do it, right? This time you will need to put more logic on your turn variable. So similarly, when number of queue grows, your logic will keep on becoming complex, right? Also, if you notice, how will you wake up a thread from a queue? So to wake up a thread from a queue, you will use a method notify, right? Notify, we have already studied what notify does, right? We will use notify. What will notify do? Notify wakes up any thread among the waiting thread without maintaining fairness, right? For example, suppose this person is waiting in the queue for 10 minutes and the second person is waiting in the queue for 15 minutes. If you write notify here, randomly any one of these two threads will be woken up, right? It is not guaranteed that the person who is waiting for the longest time will be given the chance to sit on chair and get their trimming done, correct? So there is no fairness, which might lead to starvation. Starvation means there can be a case where this thread might never wake up because waking of threads is random when you use notify. So there are two problems here. First is the logic becomes very complex when number of queue increases, right? And second problem is you cannot maintain fairness here. So to overcome these challenges of complex code to handle multiple queues and to maintain fairness as well, we have a concept called reentrant lock and condition. Let's understand what reentrant lock and condition is. So first part is reentrant lock. Reentrant lock can be considered analogous to a monitor object. So this is the object on which you will acquire a lock, right? And second part is condition. These are nothing but conditions, or you can say they are different queues or different group of threads that share a common goal. So there will be different conditions and all the threads will be waiting for the condition to become true. When it becomes true, then only the thread specific to that condition will be woken up. Don't worry if this does not make that much sense. Let's take a code example and understand it clearly. Let's take an example of printing ping pong and try to do it using reentrant lock and condition. Now pay complete attention for the next 5 minutes, okay? Because this is very important. This is a class named ping pong, okay? What is the first line? The first line is reentrant lock equals to new reentrant lock. So this is how you create a monitor object or an object of type reentrant lock, and that name is lock. So as soon as you write this line, imagine there is a queue generated in the backend which is reentrant lock queue, or you can also call it as entry queue, right? Entry queue. So imagine this queue is generated in the backend, right? What is the second line? Second line is condition ping turn equals to lock dot new condition. So a condition will always be built on top of the reentrant lock. And this is how you make a condition. So you have created a condition using lock dot new condition. Okay. So this is very important function. When you write this second line, at that particular point of time, imagine a second queue that is being generated in the backend with the name ping turn condition queue, and a second queue has been generated. Now the third line, condition pong turn equals to lock dot new condition. At this point of time, a third queue is generated in the backend which is named as pong condition queue, right? This is clear. Fourth line is private boolean is ping turn equals to true. This is just a simple boolean variable. Initial value of boolean variable is true. Now there are two functions here, ping and pong. What is written inside the function will go line by line, but before that, let's see our main function. In our main function, what we are doing, we have created two threads. One thread T1 is calling pp.ping and T2 is calling pp.pong, right? So T1 is responsible for calling ping and T2 is responsible for calling pong, and we have started the thread, right? Now listen to me very carefully. Imagine T1 and T2 both are executing parallelly. Imagine T1 is at this line and T2 is at this line, right? After the first line, T2 comes here and T1 also comes here. Both the thread try to acquire the lock using this lock method, right? So both the thread did lock.lock. Now since it is one monitor object, only one thread will be allowed to acquire the lock. Suppose T2 acquires the lock, right? If T2 acquires the lock, where will T1 be kept? So when T2 acquires the lock, T1 will be sent to the entry queue. So T1 will go ahead and wait inside this entry queue until and unless the lock is released, right? So T2 has acquired the lock, it will go ahead and execute these statements. What it will do? Try while is ping turn. What is the value of is ping turn? Is ping turn is true. If it is ping turn, then you have to go and wait, right? Because this function is responsible for printing pong. So while is ping turn, pong turn dot await. Now what will happen here? You have to wait on pong turn condition. So T2 will wait on pong turn condition. Pong turn condition has a separate queue which was initially built, which is pong condition queue. So pong turn dot await, after writing this line, T2 will go ahead and wait inside this pong condition queue. And also, whenever you call the function await, there are two things that happen. First thing is lock is released. So whatever lock T2 has acquired, it will release that particular lock and it will go ahead and wait in pong condition queue. Now when lock is released, at that point of time, ReentrantLock queue will become active because log is released. So our scheduler will go ahead and check what is there inside the entry queue. Inside the entry queue, T1 was waiting for the log to be released. So T1 will be removed from this queue and T1 will go ahead and acquire the log, and then it will try to execute these further instructions. Okay, so now T2 is in waiting condition. Inside pong condition queue, T1 has come out from the entry queue. T1 has acquired the new log. Now it is executing. What it is executing? While not is ping turn. The value of is ping turn is true. So this will evaluate to false, right? It will go ahead and print ping, right? Ping will be printed. Is ping turn equals to false. Value of this will be changed from true to false. Next is pong turn dot signal. Very important. Whenever pong turn dot signal is called, at that point of time, whichever thread which is waiting in pong condition queue will be told to wake up, right? So when we write pong turn dot signal, scheduler will go ahead and notify T2 that you have been called. So T2 will be removed from the pong queue and after removing from the Pong queue, what it will do? It will be sent into the entry queue. Okay. So after getting removed from the condition queue, all the threads go inside the entry queue. So T2 will go ahead and wait here, right? Now what happens? After this is executed successfully. Post that, catch will not be executed, but this finally will be executed. Inside this finally, what we have written? Lock.unlock. Whenever we write lock.unlock, that means we are releasing the lock. We have released the lock on this monitor object. At that point of time, again scheduler will go and check inside the entry queue which are the threads which are waiting for the lock to be released. That is T2. So now T2 will have a free hand to go ahead and acquire the lock, right? So T2, which was put in waiting state here, will go ahead, acquire the lock and start executing the further statements, right? What it will print? System.out.println Pong, right? So T2 will print system.out.println Pong. After that, is ping turn equals to true? So the value of ping turn will change from false to true, correct? And then it will do ping turn dot signal. This is also very important. When T2 does ping turn dot signal, is there any thread waiting inside the ping turn condition queue? There is no thread waiting inside the ping turn condition queue, correct? So there will be no action taken. That event will be triggered, but since there is no thread waiting inside the ping turn condition queue, nothing will happen, right? Then it will go ahead and do lock.unlock, right? Now both T1 and T2, anyone can acquire the lock, and again ping pong will be printed. But this is one of the scenario, right? What happens? Suppose when pong turn dot signal was called, right? When pong turn dot signal was called, at that point of time, T2 was removed from Pong condition queue and put inside the reentrant queue, correct? T2 was here. Then the lock was released, and post that T2 acquired the lock. What if the lock was released? At that point of time, the value of is ping turn was also false. So let me put this, right? When the lock was released, value of is ping turn was false. And after that, before T2 can acquire the lock, if T1 goes and again call lock.lock, then T1 will also go ahead and wait in entry queue. So both T1 and T2 will be in contention to acquire the lock. Now suppose again if T1 acquires the lock. If T1 acquires the lock, then this statement will be executed while not is ping turn. Now value of is ping turn is false. So this will become true. So what will T1 do? Ping turn dot await. So in that case, T1 will go ahead and wait inside the ping turn, right? It will wait inside the ping turn, removed from the entry queue. Post that, T2 will acquire the lock. T2 will go ahead and check is ping turn is false, correct? Is ping turn is false, so it will not go here. It will go ahead and print Pong as usual. Is ping turn will be changed from false to true, right? And ping turn dot signal, when T2 does ping turn dot signal, at that point of time, T1, which was waiting on ping condition queue, will come out of this queue, go again in the entry queue, and again this process is repeated again and again. So ping pong will be printed. Try to dry run further ping pongs on your own so you will get more clarity. But the main reason to walk you through this process was to make you understand what happens when you call await, what happens when you call signal, how to create different queues, right? All these things. So what are the most important things that we learned here? What are the new functions that we learned? New condition is a new function, right? So remember this. await is a new function. Await is a new function that is used on condition, right? Condition variables. Signal is also a new function that is used on condition variable. Apart from that, lock is a new method which is used on reentrant lock variable, right? So, and also unlock, yes, lock.unlock also it is used on reentrant lock variable. So there are 5 important functions that we learned here. Second thing is very important. Whenever you acquire a lock using reentrant lock, you always have to write a line inside finally, right, which will release the lock. Lock.unlock, irrespective of whatever program you write, this will be present inside the finally block, because if you don't do this, your program will be stuck forever, right? Forever the lock will be applied and your program will be stuck. So remember these functions, how do they work, as well as never forget to write lock.unlock inside the finally block. So I hope this is completely clear to you guys. If not, rewind the video, watch this part again and again, right, until it becomes clear. Now let's go ahead and run this program in our IDE to make sure that it runs perfectly fine. So I've copied the exact code that I showed you on our blackboard here, exactly the same code, right? Ping pong, we have these 2 conditions, 1 lock, we have 2 methods, ping and pong, right? And we have created 2 threads. Now let's go ahead and run this. Right, so you get alternating output, ping pong, ping pong, ping pong, right? You might be hearing some sound of my laptop because my laptop is getting heated, so please bear with me and very sorry for that. Okay, so we have learned reentrant lock, how we can write a program using reentrant lock and condition, why it is very important. One last thing which is remaining, very simple thing, is this, true. So we also talked about fairness, right? Now when you write reentrant lock equals to new entrant lock and pass a simple parameter in the constructor which is true, that accounts for fairness. So if you just write true here, your scheduler, your CPU will make sure that your reentrant lock is fair. So unlike notify, which wakes up any thread, your reentrant lock will make sure that it will wake up only those threads which have been waiting for the longest time. So that is how fairness is maintained here. I hope you liked this video, you understood each and every concept, each and every methods that I showed you in this video. So please like, please subscribe, it motivates me to make more such videos. And in our next video, we'll go ahead and solve some other problems using reentrant lock and condition, and you will see how beautiful, how powerful this is. Until the next video, stay safe, stay healthy, bye bye.